So now we have an N-channel JFET there, flat-sided left. It's a J310, and that's the gate, the source tied to the gate, and then we got the drain up on top right there. The main thing is, it's kind of like a current source. So we got 5 volts, and if I raise it to 10 volts, the current will stay the same right there. We doubled the voltage. So this is IDSS. This is how well it's going to conduct current when we just tie the source to the gate together. And different JFETs, they have a different voltage range, but you'll see when I plop this one in, okay, we got that one in, the voltage changed quite a bit right there. And I think it may go down a little bit as it warms up. But in any case, when it comes to the J310 IDSS, you should expect a minimum of 24 milliamps of current with this test and a maximum of 60 milliamps of current with this test. So now this is a symbol. Usually you don't have letters for the pins, but this is a symbol you might see for the N-channel JFET right there. There's no universal symbol though, but if you're using the TO92 package, D for drain, S for source, and G for gate right there. That's the pin layout when you're looking at the flat side. So I put the flat side to the left so that the gate was at the bottom, source, and then drain up at top. But in any case, what we just looked at was the IDSS. So that's how you test it. You just take the gate and the source, you tie them directly together, and then you put them to ground right there. And that's going to limit the current through this path based on the particular JFET's IDSS. So now, we just looked at the IDSS for both of these JFETs there. They're J310s, N-channel JFETs. So instead of a jumper for the IDSS, now we have a 100 ohm resistor right there, which is going to set a current again. So I'm going to go with the positive supply right to the transistor. So we don't have enough voltage for both LEDs, but there you can see it's letting about 13 milliamps of current flow through. So now I'm going to move this up one spot so that the one LED lights up, and it's going to be 13 milliamps of current there. You know, it's basically set the current even though the load changed. So again, we don't have enough voltage for both LEDs. There we go. But they both light up, and we have a much lower current. But if I bump this up probably 2 volts right there, we're back to 12. And I can keep raising the voltage. It's going to hold steady, although it seems to go up when components get warmer. So now we looked at the IDSS for both of these J310s. They're N-channel JFETs right there. That's when you got a jumper from the gate down there to the source. Now we also looked at the 100 ohm resistor, gave us 13 milliamps of current. We are more than doubling the resistance, 220 ohm resistance right there. So again, we're going to set a current, and we're going to go across there. It's about 7-8 milliamps of current. So it changes as you adjust the resistance. It was like 13, maybe 12 when we had the 100 ohm resistor. So there, we got one LED. We should have enough voltage to get that current again. Now the next LED is going to, take more voltage than what the power supply is providing. 5 volts to light it up. But if I get up to 7 volts, we should be back to about that 7 milliamps of current right there. And as you raise the voltage, they get warmer, things go a little haywire. So now this is the basic schematic for the last couple shorts that we did. So this is a J310 and N-channel JFET wired basically as a current source, although it's the negative side of the power supply in relationship to the load, and therefore you would call it a current sink. So it doesn't really matter what the voltage is. We got the J310. It has a maximum current it will let flow through when you tie the gate and source together. Mine are between 30 and 40 milliamps of current, but this particular J310 could be down to 24 milliamps up to 60 milliamps. There's variation even if you're using the same component. You use different components, you'll have a different range. But in any case, a 100 ohm resistor between the source and gate gave me about 13 milliamps of current, even as I added LEDs. But of course I needed more supply voltage as I added more LEDs to be able to provide that current. And with a 220 ohm resistor, it was less current. We had about 7 milliamps of current, even as the load changed.